Welcome back to another video. Today I'm talking about potatoes. I was just planting those recently and I thought I'd do a video about them because I'm trying a few different experiments. So I just want to share what I'm doing with that and just kind of see where things go from there. So I wasn't originally going to plant potatoes this year, but recently one of my neighbors came over and brought over a big crate of potatoes. I think he said there were about 50 of them. And he had just finished planting his potatoes out, and those were kind of his leftovers. 50 leftover potatoes, that's a pretty large amount. But, I was like, I don't know where I'm going to put all these potatoes. I'm already kind of cramped with garden space as it is. But I was able to find some space for them, and with a little bit of companion planting, it kind of helped make it a little easier that way. But what I want to focus on first is how I planted them. So what I did was I just kind of cut them up, making sure to keep at least 2 eyes on each tuber section that I cut up, and then I let those sit out for a couple of days to dry and harden off a little bit before I planted those out into the soil. So to kind of backtrack a little bit and go off topic for just a minute, calcium is a very important nutrient for many plants, and potatoes are of course no exception. And so calcium is needed for structural integrity of a plant. It's needed for cell wall strength, as it is a component of those cell walls and has many other functions as well. Also, there's a human nutrition aspect to it. You want crops to be able to have a sufficient amount of calcium in them so that humans can use it as a nutritious, viable food source. But there is a trick with calcium. Some people talk about mobile versus immobile nutrients within a plant. And essentially what that means is when a plant picks up a nutrient, that nutrient is moved to where it's initially needed in the plant. It may be a root, it may be a leaf, or fruit, or flower. So all of these nutrients are able to initially enter the plant. However, certain ones, and this has to do with the biochemistry, I guess, inside plants, but certain nutrients, once they get inside the plant, can continue to move in throughout the plant in order to move to an area of need wherever the plant might need to use it. Those are what we refer to as mobile nutrients, right? They can move through the phloem, so they can move up and down a plant. However, there are other nutrients that are immobile, and that is once a plant uptakes that particular nutrient and moves it to that location where it's initially needed in the plant, that nutrient can't really move anywhere else. And that's what we refer to as a immobile nutrient. And deficiencies of immobile nutrients will show up in younger leaves commonly because the plant cannot move those nutrients from its older leaves into the newer growth to support that growth. So calcium is an immobile nutrient, so it's important that the plants have a consistent supply of calcium and other immobile nutrients throughout the growing season in their proper amounts, so that these plants can continue to grow well and healthy and produce good yields. And it should also be noted that it's not always a deficiency of the nutrient in the soil that's causing the issue, but sometimes the biology in the soil, like the bacteria, the fungi, and that microbiology is not there or not functioning properly to make those nutrients available to the plants that are already in the soil. So in some cases, in a soil that may already contain adequate amounts of calcium, you may only need to boost the biology, whether it be through certain types of inoculants, compost teas, different foliar applications, soil amendments, or other factors. But in other cases, you might need to amend the soil with calcium, or it might be helpful, at least in the beginning, to amend the soil with calcium before that soil biology really kicks into action. Okay, so the other thing about calcium is, since calcium is an immobile nutrient, it's important that these potatoes are able to have an adequate supply right from the get-go. So I'm doing kind of an in-furrow application of calcium. So if I were to do a foliar application of calcium later on in the season, that wouldn't be as effective. It might help improve the above ground growth for a certain amount of time, but that calcium is not going to be able to work its way into the tubers or into the roots because it's an immobile nutrient. So it's not really designed to go down into the plant and into those tubers. So it's generally a good idea to apply that calcium at planting. And because it's a little earlier in the year and the soil is still kind of warming up at this point, I thought it might be a good idea to trial some different calcium amendments to kind of see which one works best, so that these potato plants can get the calcium that they need, hopefully, before the biology kicks into gear and is able to supply that calcium more easily in the future. So in the area where I was able to find space for these potatoes, in the first section I planted the potatoes just in the bare normal soil, not amended with anything, no compost, no fertilizers or anything like that. Then in the next section I applied a powdered calcium carbonate in with the potatoes that I was planting. And it wasn't a lot. In the furrow, I just kind of sprinkled it around the potato, kind of mixed it in with the soil immediately around the potato, and then I just kind of covered the whole thing up with soil. And so this calcium carbonate I got from drying out and powdering eggshells. And then in the next section I used calcium acetate, and this calcium acetate I also made myself from the eggshells. Actually, there's just a few extra steps in making it, and maybe I'll do a video on that in the future. And I did the exact same thing with the calcium acetate. I just kind of mixed it in a little bit with the soil immediately surrounding each potato tuber, and then I just covered it up with the dirt. And then in the fourth section I just planted the potatoes right into a garden bed that had been amended with finished compost last year. So I was able to dig into it earlier this year, and it looked like there was a lot of really good microbiological fungal activity going on in there. So my thinking here is essentially that basically the potatoes planted in the plain soil will probably yield the most modest results of all of them. And in terms of the calcium applications, I'm thinking that the calcium acetate might be more effective than the calcium carbonate. Calcium carbonate is not very water soluble, and it might take the microbiology time to really make that form of calcium eventually available to the plant, so that the plant can then use that. So I'm thinking it's probably going to be a much more slow release of calcium as compared to the calcium acetate, which is water soluble. Now my concern with the calcium acetate is, because it is water soluble, is will the potato plant be able to uptake it soon enough before the rain might kind of wash it away or dilute it before it's able to be taken up and used by the plant. And then the bed that was amended with the compost last year, I'm thinking that might be more of a dark horse candidate, but I wouldn't be surprised if that one actually ended up doing the best, because of how that soil seemed a lot more loose, a lot darker in the first place. But I'll have to do an update video on that to kind of see how these different plants are doing, to note any comparisons that might be going on. And as a final note, it's always good to do a soil test, and so that you know exactly what nutrients your soil needs, and you're not over applying or under applying any nutrients and then creating any imbalances from that point. Especially if you are a market gardener or a farmer, or somewhat more of a large-scale producer, you want to know as much as you possibly can about your landscape, about your soil, about your plants, to give you that competitive edge, and to hopefully produce the best results possible. But as a backyard gardener, I just kind of thought this might be a neat, fun experiment. But my thinking is that the calcium acetate might be able to help supply that calcium source in the short term to the potatoes before that microbiology fully kicks into gear and is able to access those calcium reserves that are naturally occurring in the soil and make those available to the plant.